So hey hi students, on this particular unit we can proceed with the support vector machines. So what are the support vector machines? This is a very very important concept. You must have to know this particular concept in depth, as well as a very important concept with respect to your gate point of view. So we can proceed with what is a support vector machine. So till now we have completed the supervised learning. We are on LDA. This is your last unit with us, and in this particular unit we can proceed with the support vector machine. So how the support vector machine works and what is the use of this support vector machine? These are some reference books because most of you are asking me again and again what are the reference books we can proceed for your preparation of the gate and your A and the ML segment. So you can go with these particular, in which I always prefer to go with some deep statistical foundations by the cited by the ML with this, along with some gold standards with mainly MIT Press notes. You can proceed to get in-depth knowledge of all these concepts. Now, thing come in your mind that what is a support vector machine? So support vector machine is nothing but it is a popular supervised machine learning algo which is used for classification and the regression part and the outlier detection. Okay, so how the support vector machine basically do? It is a type of a particular supervised machine learning technique which is used for classification, regression and the outlier detection segment. So SVM is specifically powerful for binary classification and works well when you have a number of features are basically a huge amount. Clear the margin of separations. There are the separation of margins we have. Data may not be linearly separable. Then at that case you need to be use kernels, okay, to in your particular segment to refine the support vectors. So support vectors, what it basically do, it is if anyone asks you about that, what is a support vector? So support vector is nothing but a supervised machine learning algo which is used for classification, regression and outlier detection type of things. So what it is in short, so its support vector machines tries to find the best decision boundaries which basically calculated as a hyperplane or the hyperline we have that separates the different classes with the maximum margins. So for example, if you have a class A, okay, having the point we can say that A1, A2, A3 and the A4, and we have the class B with points B1, B2, B3 and B4. So what is actually the work of the support vector? You find that A1, for example, all the classes of A1 points will remains here. That is, here we have the A1, here we have the A2, here A3 and A4 will be here, and B1, B2, B3 and B4 will be there, and this is the line which basically separates these classes and these classes. So what the SVM exactly do? SVM basically is a type of we can say that a separation line or a separation plane which can separate two or more classes by the help of the support vectors, by the help of hyperplanes, by the help of the hyperlines we have. So support vector machine is nothing but it is a method which basically finds the best decision boundaries. Okay, in short we can say that what are the support vectors? It is nothing but it is the method to find the best decision boundaries to separate the different classes with the maximum margins. What are the maximum margins we have? So that you found that these are known as the support vectors. They are supporting to find your plane, hyperplane. That's why they are known as the support vectors. And what it can do, SVM, used in the classification. You see that here you can classify the two classes. It is used in the regression part. I hope you know the meaning of regression as we have already studied multiple times. So you can found with this example that it will helpful in the regression task also. So proceeding further, what is the key intuition behind the regression or the SVM? So you found that among all the possible separation lines for the hyper or the hyperplanes we have, which are separate the class best. Okay, which are the hyperplanes which can separate your class in the best manner is known as your support vector machine. Okay, so what basically do it decides that SVM chooses the hyperplane that maximizes the margins and the distance between the hyperplanes and the nearest data points for each class. Okay, so in this case, what it can do, it can maximize the margin, the distance. What are the margins basically we have? We are the margins with, we can say that the distance between the hyperplanes and the nearest points from each class. So here you can find that they are the two different classes we have. So these are the points we have in this act as your margin point of view, okay, which can easily separates your classes in the two different manner. Now, so the nearest point data points that lie in the margin boundaries are called as support vectors. Okay, so a definition of support vector is clear to all of you, that it is the nearest data points that basically lie on the margin boundaries are called as support vectors. So these vectors completely determines the decision boundaries which you have. Okay, these basically separates the decision boundaries which you have. So these are basically the outliers we have. Here these are the outliers. This is class A and the class B in this particular segment, which are your support vectors right now. So support vectors are looks like this. These are the outliers point. So you found in the initial slide, if someone asked in your interview, in your paper, and in the any MCQ, so even in the gate also you have found if theoretical questions that in the MCQ what the SVM is useful and where the SVM is useful, the classification, the regression problems, and the third one is the finding the outliers. You can see that by the use of the SVM you can easily find the outliers. Okay, by the use you can separate the two different classes. So a basic intuition or basic understanding is developed between you that SVM is a type of technique which can be used to classify the different classes. Okay, so I think now the things is much a basic understanding is developed that what are the support vectors. These are the support vectors, any classes, and this is the support vector plane we have, which is known as a hyperplane with us. Proceeding further, we have why the maximum or maximize the margin we have. So the bigger the margin means the better generalization. What the better generalization we have with the more robust to the noise and the outliers. Okay, so here lower the chances of overfitting. So more you have the margin, then it basically reduces the chances of overfitting. See here, since margin distances are more, you can easily see even the data is more and you increase the margins. So at that point overfitting cannot be possible. Okay, more the margins will be there, overfitting will be reduced. Even you can eliminate the overfitting segment by the use of the SVM. So SVM, why maximize the margin? The reason behind lower the chances of the overfitting. Why we always focus on maximizing the margins? Why we can focus on the maximizing the margin? The reason behind that it will reduce the segment of overfitting. It will robust to the noise and the outlier. There for the better generalization, you can better generalize the two classes in a particular segment. So SVM prefers the widest street between the two class. How does SVM algorithm works? So there are the few steps through which a particular SVM algo works. So in which the first step is the represent data points in your spaces. Okay, first what you can do, for example, if you have a data point 0, 1, 0, 1, 2, 1, 3. So how you can first ever work is your, for example, for your class A it is. So you can just mark this point. This is 1, this is 2, this is 3. So 0, 1 lies here. 0, 1 lies here. 1, 2 lies here. And 1, 3 lies here. So first what you can do, you can locate your data points. This is A, this is B, and this is C. So 1, 3 is C, this is B, and this is your point A. So first, what's your activity is you first locate the data points. Okay. So each training example is a point in the simple n dimensional space where n is equal to the number of features we have. Next, find a separating hyperplane. So second step you need to be do whenever you can proceed with the SVM, that you need to be find the separating hyperplane there. So for the 2D, hyperplane is the simpler line For the 3D, hyperplane is a simpler plane. So for the higher dimensions, a hyperplane is greater boundary surface. So a goal is to find a hyperplane that separates the class correctly and has the largest margin in your particular classes. Now, third step is the compute the margin. So, how you can compute the margin? Margin is simply the distance between the hyperplane and the closest points for each the class. Okay, so third segment is you need to compute the margin. First, you locate the points. Second, you try to locate the margins. Then you compute the margins. So the closest points are the support vectors. I hope this we have already studied that what are the closest point. So in this slides, in this particular segment, you can easily see that closest points are known as the support vectors. You can locate the support vectors now. Now proceeding for the third points that compute the margins and the support vectors. Fourth point. Now, SVM mathematically solved by 2 divided by their weights, that is W, which is the subject to constraint enforcing the correct classification. So, this becomes a complex optimization problem solved using large multipliers as well as the quadratic programming. But I hope that much in depth they cannot go in your gate examination. So this can be easily be sustained only for the from the previous 2-3 years. I have seen the basic questions they are asking. Simply you can just locating the points and you can easily found the hyperplanes of the support vectors, and you can easily mark the questions answers in your gate examinations also or in any examination. So step 5, if the data is not linearly separable, then you can apply the soft margins there. Okay, if data you are unable to separate that particular data, some datas are coinciding, so at that time you can use the soft margins. So soft margins, real data is noisy, so basically perfect separation is very rare. So at that time a concept of soft margins come. So allow some misclassifications but penalize them with the parameter C. Okay, but just simply penalizing them with the parameter C, and this parameter C is high, means less tolerance to misclassification, that is risk of overfitting. So you need to reduce this C. So low C will basically more tolerance, that is more generalization will be there. So if your C value is less, that means it is more generalized. If your C value is high, that means your risk of overfitting is high. Okay. So if data is non-linear, use the kernel trick. This is the step number 2. I hope using the kernels in your particular SVM will not in depth they can go. If the kernels concept comes, that that question will becomes a 2 marks question. Basically these kernels question is asked in the ISRO and the DRDO papers. So that is not that much important with respect to the gate examination point of view, because see there are the lots of things to study in the SVM, but what's our focus, what's important with respect to your examination? You are preparing for the gate or a simple interviews examination you have, so or the simple basic things you are dealing, simple competition examinations you are encounter. So these simple questions you will found in a very simple manner. This kernel concept using the kernels is makes the question more complex. That much time if you are investing in a single question of 1 marks, that is not I think fruitful. So at the time if you any choice of leaving the question, then you can leave the question, because making the question more complex and wasting lots of time in that, invest that particular time in some another question. Okay, so sixth is the, if no linear database cannot be separated by a straight line, then use the kernel trick, in which you can just use the kernels, that is by transforming a data to a higher dimensional using the concept of kernel, where separation become easily possible. So kernel type is linear, polynomial, RBF and the sigmoid. These are the different kernel types we have. For the linear, it basically works with simple, we can say that separable data. In this, we can polynomial adds the polynomial features. RBF Gaussians maps the data into the infinite dimension space, and sigmoid is similar to the neural networks. Now this is the 2024 PYQ questions of the gate which is asked. This is a very simple question. I hope if you can, this is looks like a bigger question, but what the first step you can do, first step you just make the points, make or sketch the points, or we can say that locate the points on the Cartesian coordinate. First, you can do that. So there are the certain points 1 comma 0. This is x1 with 1 comma 0. x2 you have 0 comma 1. x3 you have with 0 comma minus 1, and x3 you have with minus 1 comma 0. x5 you have with 2 comma 2. x6 you have with minus 2 comma minus 2, and the labels with y2 y5 is with the 1, and y3 y4 y6 is with the minus 1. Now these are the hard margins and all these things, that much is not important. A basic concept, you have to be focused the basic data which is helpful for solving that question. So one of the following set is possible for the support vectors. So what are the support vectors? What are the support vectors? Example, that if this is the hyperplane and if this is the line you have, then the closest point to this particular line is your support vector, okay, which is used for them. So just simply you need to be locate that point on the hyperplanes, okay. You just simply locate those points. We have the points on simple locations you can make, okay. Here are some simple points. Do not take that much of time in solving such a silly and the easy questions. It looks bigger, but if you know the concept, it will be solved within a seconds, okay. So this is minus 1, this is minus 2, here minus 1 minus 2. So it is 1 comma 0, that is 1 comma 0 will be this point A. This is 0 comma 1, this is a point A, not x1. This is 0 comma 1, so this is 0 comma 1, this is point x2 you have. Then 0 comma minus 1, 0 comma minus 1, this is the point x3 you have, and minus 1 comma 0. So we have the minus 1 comma 0 is the point we have. So this is the x3 I think, and this is the x4 you have, okay. Then x5 is 2 comma 2. This is 2 comma 2 you have the point. This is your x5, and x6 is minus 2 comma minus 2, which is this point, that is x6 you have. So these are the all the points you have. I am just highlighting these points so that you can easily understand that these are the points x6, this one, okay. So we have these total points in you, and this is the x2, okay. So it for you, I think it is can easily see that this is the simple line or the support vector lines or the hyperplane you have, and these are the support vectors. Only this is the program, this is the question. So if you just your 80% question is solved if you just plot these questions. So plot these points. So you have seen that x2, x4, x1 and all these things where it is looks. So where x2, x1, x3 and x4 looks, that is your answer. So answer D is your correct option. Okay, this is that much simple. But if you want some more clarity and more confidence in that question, or you want that right now 98% the option you have marked is the correct. But for example, for the 2% if you are in the doubt, just check that. Okay, just do this exercise, just points x1, y1, x2, y2 we have x3, y3, x4, y4, x5, y6 and the x6, y6. So using this particular equation, you will found that support vectors are just simply y equals to mx plus c format, in which m will be your weight and c will be your bias, which is also equal to 1, and the node support must satisfy this particular, must be greater than 1. So just simply with all the positive signs, A will be rejected. Why? Because it do not contain, you can see by the elimination C. So it is contain all the positive things, that is x1, x2, x5. Both are the positive. x1 is this one, x2 is this one, and x5 is 2 comma 2. No negative pointers will be there. Okay, here you can see 0 comma minus 1, 1 comma 0. So A is directly neglected, B neglected, C neglected. Only a 1 where all the things can be occur, negative and the positive, both the cases will occur, is the section, is the option D. So you can directly proceed with the option D also. So 1 is rejected. Why? Because of this. Why the option D works? Because when you find all the weights, all the conditions satisfy, you can take the snap of this if required. And although in the examination, don't waste that much of time in calculating all these things. Just proceed what we have seen. By what you are doing, you are putting the value of x1 here. Okay, thinking the bias equal to 0. That means the simple thing which we have already done in the previous two slides. Okay, so they are putting bias equal to 0. That means making the bias unusable. So weight is equal to 1 comma 1. That means the same equation will be there. So y equals to the mx plus c or WTX plus B, you make B equal to 0, you make WT equal to 1, only Y equals to the X, that is Y is proportional to the X. Then why you are going in that much of calculation? Directly put Y equals to the X, okay, which we have already done, and we can satisfy the answer. That answer is nothing but D. Okay, we just directly put Y equals to the 1 and put in the pointers here and just get the answers. So this is only the 20 seconds question which we can easily solve. So this is the complete session of support vector machines. I hope you like this session. This we have done in a very precise and the manner for your crash course point of view. So I hope you all like the video. Thank you so much. Have a nice day. Take care, students. We'll meet on the next video.